Welcome to 4.6. This is a topic about watersheds. I put this photo in here. This is a great example of a watershed. So this is my hometown. I live kind of like up in here. And this entire area here, all these mountains, even the mountains behind it, going around, there's another mountain on this side, all flows into this river here. This is the Yampa River. And this is an example of a watershed. You have a massive creek running down from here that goes in, another one coming from here, and then we have another one coming from here. So all these little creeks are all going to run into one large river, which will then carry that water farther down until it eventually reaches an ocean. So watershed is an area of land that's going to drain all of the precipitated water, all the runoff, all the rainfall, all the snow from up in the mountains, all the groundwater. It's all going to flow down into this one area, and all the water is going to join into this one river. And that is going to lead into a discharge point. So this discharge point is where I mentioned before, where all the water moves into before it's carried out of that watershed. Watersheds can be small, like almost the size as KIS, but they can also be massive. And I wanted to show you this one. So this here is a great example of a watershed. Everything that rains in this spot on that mountain right there, that mountain, these hills, is gonna run down into this water here, and that is all gonna flow down into the Pacific Ocean. So everything that is around this area is part of that watershed. Any water, any runoff that's gonna trickle down into this river, and then this river is gonna run down through Sirocsan Park and into the Pacific Ocean. So a great little example here. So this is the watershed for the Yangtze River in China. Massive. I mean, we're starting all the way up here with snow melt. And all of these rivers all up in this area are all going to drain down. So lots of mountains up here with a lot of snow. And then all of a sudden our river is going to get a little bit bigger here, more things adding to it, much larger here. There's actually a big dam right there. And then it just gets larger and larger and larger as we make our way all the way to Shanghai. Everything in this massive amount of space is all draining into this Yangtze River. Now, the uppermost part of the water, this is the headwaters. This is normally snow. It's a lot of snow melt. It could also be springs, it could be runoff, but most of the time it's up in the mountains and it is snow. Now, a divide is a boundary between one watershed and its neighbor. The United States has a very large divide that actually splits the entire continent in half. What that means is that along this ridge line up top here, we have some of our tallest mountains, and water that falls on this side is going to go off into the Atlantic Ocean, and water that falls on this side is going to end up in the Pacific Ocean. So it actually is just a ridge line, and I think this is very interesting. So again, if you take this photo here and you kind of split it in half, all water that falls on this side is going to head to the Atlantic Ocean, and all water that falls on this side is roughly going to go to the Pacific Ocean. So you could have this one storm, and it just depends which side of the ridge the water falls on. It's going to end up in totally different places. The lower end of a watershed is called the outflow point, or sometimes it's also called discharge point. This is normally going to be a river or a lake that leads into the ocean. So this river here will keep running, and then eventually it's going to discharge into the ocean. All water in that watershed is going to pass through that outflow point. So as I mentioned, back in Colorado, you have the Colorado River, which flows from here, and then it comes down and through this way. And so its discharge point is actually the Gulf of California, which is down in this area, which will then merge with the Pacific Ocean. Important, though, is that along the way, we're going to have pollution that's going to enter into the river. So if my pollution enters in at this point, it's going to be carried all the way through the watershed until it hits that outflow point. So as I mentioned, if we have contamination that's introduced, unfortunately, it's going to affect all downstream points after that. So if I introduce pollution right here, that means that the water that is above it is quite clean, but everything below it will all have potential for that pollution to make an impact, unfortunately. So this is a topographic map. Most of the time we use topographic maps to predict the watershed for an area. What we can look at is the highest points. And when we outline our highest points, we're going to find that the ridge, it says upper ridge here, is where the highest point on this topographic map is. And so it helps us get a better sense of the watershed for this area. Clearly, all of our water is flowing down in this direction, and then it's all going to move in an outflow point that is somewhere down here. So we can use these topographic maps to help us get a better understanding of different watersheds that exist. Now we can characterize these watersheds based on 1, 2, 3, 4, 5, 6 different characteristics. So first, the area, how much space it covers, the length, how far the water is sourced, and the final location. That's a big deal. The slope, the soil, the vegetation, because that will determine the amount of the runoff, and then of course any adjoining watersheds that they drain into. All right, so let's talk about area. The area covered by a watershed is this indicator of how much precipitation it will collect. Obviously, the larger the watershed, the more water it collects, and the greater potential we have for flooding, unfortunately. So again, it's a great way for us to predict by looking at the area what our potential impacts on flooding are. Length is another one. This talks about the distance that is being traveled by that water from the headwaters to our discharge point or our outflow. This length is determining the amount of time that the runoff stays in that watershed. So it takes 90 days for water to flow from the headwater of the Mississippi River all the way to the Gulf of Mexico. That's a long time. So just keeping that in mind. It's also a way that we can track the impacts of pollution and how long it will take for pollution to reach a certain point and so on. Slope gradient, you guys know this, that a steeper watershed, we're going to have faster water, we're going to cause more erosion, and we're going to have more runoff. We're not going to have a lot of infiltration in groundwater. So it, again, is a predictor for erosion, potentially mudslides, and allows us to get a better understanding of the impacts of these rivers. In addition, if I have a low gradient, so that means not very steep, we're going to have a lot of sediment deposited along the way. And we've talked about that previously. Soil is another indicator for us. Now, we've talked about soil so far, so we know that some soils have a lot of sand. And when we have those sandy soils, they actually reduce runoff because we can have more infiltration through the sand that becomes groundwater. This is the opposite if I have a lot of clay in my soil. Clay prevents this infiltration, and therefore we're going to have more runoff. We've noticed that most of the time when we have low gradient regions or not very steep regions, we're going to have this deep, silty, nutrient-rich soil, which is fantastic. And that's why these areas are used for agriculture, because this is great soil to be planting in. And then finally, vegetation. As you know, plants, especially trees, are going to reduce runoff, which is going to increase our infiltration and our groundwater. In addition, anytime we have decaying plant matter, it's going to add those nutrients back into that watershed. It's super helpful. And unfortunately, when we start removing trees from a watershed, especially on our steeper sections, we are going to increase runoff. And if we increase runoff, we're going to get flooding. I would say this is a super important section here for you to circle. So if we remove those trees, we're going to get increased runoff, flooding of that lower sections of the watershed. So just things to keep in mind here.